If you have time, you can just join till now, till the last, or otherwise you can.
Yes, madam. Yes, madam. I can continue for
Okay,
some time.
fine.
Right.
Okay, fine.
Thank you. Thank you.
So, yeah, so today we will talk about the exam based suggestion as I just told right now. So, today basically what we will do, we will simply tell what will be the question pattern and what will be the, I mean, which topic will be the most important for our examination, because you know that like knowing all these things, that is very good, but examination marks is also very important for us. So, before going to the main topic, I just want to tell you that a notification regarding admit card will be provided via email and SMS, because previous year or the previous to previous year there were so many questions coming from the students that when the admit card will come and how it will come. So I just want to tell you that the notification regarding all the admit cards and all these things will be provided via your mail ID, your SMS. So there will be no problem on the getting the admit card. You can get the admit card more before the, I mean, very before the examination time. So it will not be that much problematic. Now you just focus on your work. That is the thing. Okay. So okay, so what I have make a slide here. I just make a slide about the total marks, number of questions, and what type of question will come in which number. So the total marks will be 100. Okay, I think someone had joined. Maybe let me check. Okay, fine. If you people, can you hear me? I think yes. Yes. Okay, fine, fine. Thank you. So there will be 50 total questions, and each question will carry 2 marks. So that means total marks will be 100. Okay. Now, among these 50 questions, what type of questions will be there? So I just wanted to break down that 50 questions so that you can understand clearly. So first of all, let me write here something. Obviously, I have written here so many things, so you can just read that one and you can understand what is this meaning. So among these 50, there will be, I told you that there will be 50 total questions, and each question will have the 2 marks. So that means total marks will be 100. So among these 50 questions, how it will be distributed? 15 question will be MS type question. MS type means multiple choice, I mean multiple selection type question. Matlab, means more than one option will be correct. It is not that only one option will be correct, more than one option will be correct. Obviously, MSQ, this term you are very much familiar with, that NET, GATE examination and all these things. So I am not gonna explain this MSQ anymore. So 15 question, first 15 question will be MSQ type, and most probably, obviously I am writing, I am emphasizing this most probably word. Most probably it will be directly linked with present and previous year assignment questions. Okay, like there were 12 week assignment, right? So 12 week, and in every week there were like I mean on an average 8 or 9 questions were there per week. So that much questions, as well as, I mean, this is the present year question as well as previous year question. Previous year questions, I and one of the another TA were solving. So these questions as well as present year assignment question, you can, if you cover all the questions, maybe you can find directly 15 questions among 50 questions. Okay. Okay. So actually this should be Q. Sorry. Again there will be 10 questions. Okay, 15 question is already done among these 50 questions. Now the next 10 question. Next 10 question will be again MSQ type question. More than one option is correct. And that will be straightforward and direct question. Straightforward and direct question means, obviously you can understand, let's say I am talking about, let's say I am, as an example I am telling that like photon is a mediator of which interaction. There are 4 options like weak interaction, electromagnetic interaction, strong interaction, gravitational interaction. So obviously the photon is the mediator of weak electromagnetic interaction. So that type of questions is there. I mean very straightforward and direct question. So that will be 10 questions. Now coming to rest of the 25 questions. Now we got 15 questions, then 10 questions, then 15 plus 10, that means 25 questions are already done. Rest of the 25 question we need to take care. So basically I can tell that rest of the 25 question will be little bit open and more involved on the topic, and it can be a little bit tricky. Okay. So among these 25 questions also there are 10 questions who are MSQ, and again MSQ means more than one option is correct. And the rest of the 15 questions are short answer type question. Short answer type question means mostly will be numerical. Numerical, like you understand, numerical means there will be some like mathematical problem is there and you have to solve the problem and you can write the answer on that question, I mean screen. So these are the 50 questions I'm talking about. If you have any doubt regarding that 50 questions, just unmute yourself and let me know. Okay, maybe I can just summarize that one a little bit quickly again so that it will be very much understandable. Among these 50 question, first 15 question will be MSQ type, and that will be directly linked with present and previous year assignment questions. Next 10 questions will be straightforward and direct. Rest of the 25 questions, among these rest of the 25 questions, 10 questions will be MSQ type. Remaining 15 questions will be short answer type. Short answer type means it may be mostly numerical. And these 25 questions will be little bit more open and more involved on the topic, and it can be a little bit tricky. Obviously don't afraid of all these things. Tricky means obviously it's not that much tricky in a very, like let's say UPSC exam or something like that. It will be not that much level, but you can do that, that's it. Okay, yes. Now if it is clear to all of you that how these 50 questions is distributed, then we can go to the next slide where I have shown that from my personal view which topic can be the important one. Obviously nuclear and particle physics course, each and every topics are very important for our examination, but as a quick reminder or something, quick revision, we can't cover all the topic in equal importance, right? So what I was thinking to list a little bit number of important topics among these nuclear and particle physics course, so that you can have a little bit more stress on this topic. Obviously you have to give more stress on the others ones, but I just mentioned here little bit. So important topics as per I understand, so I have just listed here a little bit. First of all, I just listed here radioactivity. Radioactivity means radioactivity questions. So first I can tell you one simple trick, that radioactivity means every time you are having this type of things in your mind, right? N equals to n0 e to the power minus lambda t. So this will come automatically in your mind when we are talking about radioactivity. Okay, and there are, I mean, 90% questions on radioactivity in any competitive exam is coming only based on this expression. So it's very simple to understand, to read the topic, to answer all the questions regarding radioactivity. Okay. Now coming to nuclear cell model. Nuclear cell model means obviously we have done so many questions regarding nuclear cell model. Nuclear cell model questions means spin parity calculation. They will give us one, let's say Mg1221. Then in that nucleus, what will be the nucleus, I mean the ground state spin parity, or what will be the first excited state spin parity, all these things, second excited, third excited state spin parity, all these things they can ask. Okay, now in the third option I have written here binding energy. Binding energy, obviously you can understand binding energy calculation for beta minus interaction, for beta plus interaction, for alpha decay, and all these things for, let's say, there can also be some numerical problems on the binding energy, semi-empirical mass formula, that type of things can also be done. And then let's say, I mean, I'm just giving an overview of all these things, right? I'm not giving a specific thing today. Just a minute, my charger laptop is getting. Oh, just a minute. So this type of things you can have in your mind. Then, yes, so binding energy calculations. Now the fourth one can be the relativistic numerical problems. Relativistic problems means the questions regarding the special theory of relativity. Special theory of relativity and all these things, right? Now there will be allowed. Now in the fifth one, I just put here that allowed and not allowed nuclear reaction. Like, I think you have already familiar with all these things. Like, maybe there will be some nuclear reaction, and they will ask that the nuclear reaction is possible or not. So for this case, what you need to check? You need, at the very first, you need to check Q, L, and B. Like the charge of electric charge of the nuclear reaction. I mean, left hand side and right hand side should be equal. Then the lepton number means Le, L mu, L tau, each should individually satisfy, each should individually conserve, right? So lepton number violation should not be there, and B for the baryon number violation should also not be there, and like that, nuclear reaction. Now in the next topic, I just mentioned here A plus B going to C plus X. What is X? That type of question can also be there. That is very simple question. And you can understand that each question has 2 marks. So that means there will be not that much difficult question for everything, right? So this type of question can be there. What will be the X? You can find the X with the help of Q, L and B as well. And again, if it is a strong interaction, then we have to check the strangeness quantum number as well. I mean, like, for strong interaction, strangeness quantum number should be conserved, right? Okay. So then this is the thing, and then the next topic can be the gauge transformation. Gauge transformation means, obviously you can understand, like, that type of transformation, if it is there, then F mu nu is equals to F mu nu prime is or not. That they may ask, or something, let's say A mu is invariant on this transformation or not. These all the things we have already done previous to previous year week. So it's already done, and maybe there will be some question on that also. Now coming to the next topic I feel that the field tensor and dual field tensor. Field tensor is nothing but this one, and dual field tensor was F mu nu tilde. So there was a relation between F mu nu and F mu nu tilde, and there was again a relation of like E mu, then B nu, all these things are there. Like F mu nu is a matrix form, as I think you remember these things also. So this is a matrix form where E mu and B mu are there. So you can find these things, right? So they will ask that what will be the F01, what will be the E0, what will be the E1, something like that. Like we know that like F0I is like EI. It's there in one of the assignment question, right? So you can see that one also. Then the last topic, I thought that it will be a very much interesting, like accelerator. Accelerator means like cyclotron, Van de Graaff generator, and then what else, like cyclotron, synchrotron, all these things are very much important for our mathematical calculation, as well as for the topic wise essay type question as well. So for cyclotron or Van de Graaff generator, basically for the cyclotron, what they are asking omega, they are asking F, they are asking B, that type of things are there, right? Omega is the frequency, angular frequency, and F is again the angular frequency, B is the magnetic field, value of the magnetic field. There they can ask the value of the magnetic field. what is the, I mean, in that magnetic field, how, I mean, what will be the magnetic field, so that the particle will get accelerated in the cyclotron. This type of things, you know all these things very well. So I'm not gonna tell any detail of these things. But I thought that this type of point, whatever I mentioned, that can be a very much important for our numerical calculation, obviously, but as well as for our other simple MSQ type questions also. Okay. So if I miss something very much important, then obviously let me know, so that every other one can also get to know that, okay, that may be the important one. Okay. So this is the thing. Today actually basically it will be a little bit more interactive session, because today I'm not gonna tell any previous year assignment questions, right? Today what we will talk basically which one can be the important one, what is the question pattern, what can be the important question for our examination, like that. So if you have any comment on that, you can unmute yourself and you can tell me, so that every other one can also know that. Okay. Okay, so what I did, like till now, in these fourth slides, what I did, the examination pattern, then the important topics I just discussed. Then I thought that, okay, why not we will tell something about the questions, what may be the examination based question. Obviously I don't know what will be the question in examination, but whatever we can try a little bit more, that may come in our examination, or similar to that may come in our examination. So what I mentioned here some of the questions, important questions, what I felt, and then we will just think a little bit on these questions, so that we can answer all the questions very correctly. Okay. So let's start the first question. Obviously, it is not coming from any previous year assignment question. That is simply a very simple methodological question, you can tell. So which of the statements below are correct? Why I have mentioned this type of question? Because you can see that among these 50 questions, I think most of the questions were related to MSQ only, right? So MSQ was there, that more than one answer should be correct. So that's what I mentioned here. Which of the following statements below are correct? It may be, I mean, there are 4 options.
It is one is correct.
Okay, good, very good. Yes.
One is correct, and as well as third one is correct.
Third one is correct. And another? Is there any other correct?
4, madam.
Fourth one is also correct. Very good. So photon is a spin 1 particle. Then as per QED, photon is strictly massless. Obviously, photon is strictly massless. Photon is electrically neutral. That means A, C and D are exactly correct. But what about B1? Freely propagating photon has 3 polarization state. That is not correct. It has 2 polarization state, 2 longitudinal polarization state. Sorry, transverse polarization state. So A, C, D can be the correct option. I mean, see, I just told you the type, what type of question can be there. So, yeah. That is also a very simple question. Just see the question and tell me the answer. Which of the following is an example of strong interaction? Beta decay, gamma decay, stability of the nucleus, alpha decay.
I think it is C and D, I think.
There will be only one answer.
One answer, that is C, madam, I think.
Yes, alpha decay is not coming from the strong interaction. So C.
Okay.
And these type of things are very simple. So I'm just going to recall all these things with you people. Okay, what is the mass number of a nucleus with radius 5.60 Fermi? Use Fermi, give your answer in integer value. Just do calculate quickly, because you all have calculator in your laptop, in your mobile, in anything. Okay, so for that what we need, first of all, whatever it is given, I will just write quickly. I mean, that is the best way to do any mathematical calculation, that whatever is given in that question, you just write it down. And after that, you will think what we need to know. Okay. So what is given here? R is given here, 5.60 Fermi. Now, what is the mass number of the nucleus? And mass number means A. So, what should be the expression for this calculation? The expression should be like R equals to R0 a to the power 1 by 3. Okay, I forgot to mention one thing also. Yes, sorry. I forgot to mention that this examination will be a computer based exam, right? So, whenever you will go in front of the computer, then you will see two things. One thing you can see that online calculator, and I think most of you have already got to know how to operate online calculator, so that is there. And the another one will be there, that there will be some important parameters value, like let's say I can tell you h bar value, c value, h value, r0 value, then pi value. This type of values they will already provide on the screen. So you don't need to remember all these things. And then k value, then sometimes maybe it happens that 1u equals to 931.5 MeV. This type of conversion is also there. That can also be possible. So I just want to tell you that you don't need to remember all the constants, I mean universal constant. You just need to think about your calculation, about your mathematics. That's it. So for this question, you don't need to remember R0. Most probably R0 will be given, and we know what is the R0. R0 is the average radius of hydrogen. So you can put the value of R0 from that list. Yes. So R0 is given as can you for some time mute yourself? I'm really sorry, but okay. So R0 is obviously given as like 1.25 for me. It will be given, no problem on that. You don't need to remember. So if you put these values, R value and R0 value, then what will be the value of A? That's it. So can you calculate quickly? I'm also going to calculate that one. Yes.
90, madam.
Yeah, very good. 90.
89.91.
Yes, but obviously RA means it will be a mass number, so mass number can be in the integer number, so it will be of the order of 90 only. Okay, so for other students who did not do that one till now, so I am just writing here 5.6 divided by 1.25. Then A can be written as like 5.6 divided by 1.25 whole cube. If you just calculate that one, it will be coming as of the order of 90 only. Okay. So this type of question can also be there. I am just calculating here a reference. I am not telling that it will be in the examination. Okay. Okay. So these are the very simple questions, as you can understand. Now coming to this question as well. Mass of, okay, just remember these are the very simple question, but you should not do any mistake, because in most of the cases simple question have a very large chance to do mistake. So don't do any mistake in your examination. Okay, mass of P1541 isotope is this one, taking mass of proton and mass of neutron as this and this respectively. Its binding energy is this one. How much? To 1 decimal place in MeV they are asking. So maybe I will do, or you people can also do, that is also very good. You have a calculator, but let's start with me as well. So for this question we have already done so many times this type of questions. So P1541 means I can directly write it like proton number is 15, neutron number is 41 minus 15. So 41 minus 15, it will come as 26. Okay. Now we got to know from this notation that for P, proton number is 15 and neutron number is 26. Very good. Now what we will do with these things? They told that mass of the proton, only one proton, mass of the one proton is 938.3, mass of one neutron is 939.6. So obviously we will do one thing, 15 into 938.3 plus 26 into 939.6. We will do that one. So that will give us the total nucleon mass, right? So that will be, obviously you have to take care about the units and all, that will be in MeV by C square unit, okay? And they are asking that you have to give your answer in MeV unit itself. So we will stick our calculation on MeV by C square unit only. Okay, so if you just calculate that one, maybe someone can do that one, or I can also do this with my calculator. Okay, so what will be the answer for that? 15 into 938.3 plus 26 into 939.6. So it is 38504. 38504.1 MeV by C square. Okay. So this is the nucleon mass. Nucleon mass. Now what is the nucleus mass? Nucleus mass is 40.99465 U. Now just remember here, this is written in U unit. So we have to convert that U unit in MeV by C square, right? So 1 U is 931.5 MeV. So you can just multiply this whole with 931.5, which you will get like 40.99465 into 931.5. So this much. I'm just going to copy these things because I don't want to write this again. Oh, it will not be copying. Okay, fine. 38186 5164 MeV. Okay, one more thing you can be little bit problematic for you, that there is MeV by C square and we are talking about 1 U in MeV unit. So there will be this one also, but just make sure that we are talking care about the natural unit. For natural unit C is 1, so we don't need to bother about C as well. So this is the nucleus mass and this is the nucleon mass. So what will be the Q value? Actually they are asking that binding energy, that means Q value. So Q value will be simply nothing but this nucleon energy minus 38186.5164. So this will be the nucleon binding energy. I mean, we have done this thing so many times. So 38504.1. Yeah, like obviously that will be a minus 1 because this is the one. So 317.58. So that is in MeV unit, right? So you can see here 1 decimal place in MeV unit. So they just want this number, or obviously you can write it like 6 because it is 58. So it can be rounded off by 6. Okay, one more thing I just want to mention you, that whenever this type of question will be there in examination, where this, let's say some more terms were there, right? So let's say we have so many terms after decimal, so we can write after rounding off this term, or we can write only this one also, because in this type of decimal question, maybe one can get a little bit different answer from another, and obviously not that much different, that will be only differ by the decimal one. So people, I mean whoever will evaluate, they will understand your problem, that you are not going to take all the numbers after decimal. So you will obviously take after 2 to 3 max to max 3 decimal place after, I mean 3 terms after decimal place. So it's very fine that you will take let's say a rounding off or without rounding off. That is also fine, no problem on that. But the main thing is you have to reach within this limit at least. It should not be like in your question 310. It should not be the correct one. 317.5 or 317.6 both can be the correct option, and obviously they will take care of this one, but it should not be more than that or less than that. Okay. Okay. I think it's also very much understandable by all of you because it's also very much simple. They just wanted to know the binding energy of that reaction, I mean of that isotope. That is the thing. Okay. Now maybe I can come to the next question. Yes, next question. Next question is again the very simple one. You can see this is related to the radioactivity, and radioactivity means obviously I told you so many times radioactivity means only one expression is enough for all 90% questions. So I am just going to write it blindly what is the expression for radioactivity. Now I will see what we need to check. Radium-203 undergoes alpha decay. Okay, very good. With a half-life of 4 millisecond. So half-life means T-half. T-half is 4 millisecond. Why I am writing here full? Because you need to check the unit in physics calculation. That is very important for all of us, right? In physics we need to check unit very carefully. Here you can see that the time, the second is given in millisecond unit, and even also here also it is given in millisecond unit. So if both the things are given in millisecond unit, then we don't need to take care about the unit right now. I am emphasizing this one because there are so many mistakes we are getting from the previous year students that they are forgetting to change the unit in the proper manner. Okay, so just be sure on that. Okay, so half-life of alpha decay is 4 millisecond. That means T half equals to 4. At time t equals to 0, pure sample of radium-203 is taken with N0 atoms. If 3125 radium-203 atoms remain in the sample after 20 milliseconds, what is the value of N0? I mean, they just wanted to know the value of N0. So I am quickly writing the value of N0. N0 will be like N, then e to the power lambda t, because it will come here. Okay, very good. So what is N here? N is already given here directly, 3125. Okay. So this is given, and T is given as 20 millisecond, right? After 20 millisecond. Now we need to know the lambda value only. So lambda is already given. Lambda is what? Lambda is ln2 divided by T half. So 0.693 divided by T half. Okay. So yeah, fine. So ln2 divided by T half. Now if I calculate the value of lambda, the lambda will be like 0.693 divided by 4, 0.17325, 17325. This is the lambda value. Okay, I got the value of lambda as well. I have the N, I have T, I have all these things. So I will just going to put all these values. This is 13 something 25, no, 3125. 3125, then e to the power 0.17325 into 20. 20 millisecond is there, right? So it will be 20 only. So if you write the value, if you just calculate this one, then you can get the value of N0. So let me write here quickly what will be the value of here obviously e to the power something which is like, okay, maybe I can do that one. 0.17325 into 20. This is 3.465, and e to the power means, if I am not wrong, then I can write it like that only. If I am not wrong, I think this is the correct one to write the e to the power in this calculator, but just make sure that it is the correct one, and then you will just 3125. This type of things are there. So that much. Oh, that will not gonna copy. So N0 is of the order of like what? 99926. 99926.43. But N0 should be in integer number, so 99926 only there. But please make sure that this e to the power will be the actual one, whatever I was writing here. Just this is simple mathematical, calculator thing. But the expression for this radioactive question is only n equals to n0 e to the power minus lambda t. That's it. Okay. Okay, so this question obviously is very simple question. Can anybody tell that? W bosons mediates which? Anyone?
Weak interaction.
Weak interaction. Very good. Weak interaction is mediated by W plus W minus Z0. This two. And I can write it that electromagnetic interaction is given by gamma. Strong interaction is mediated by gluons, and gravitational interaction is graviton. But obviously, in nuclear and particle physics, we are not talking care about graviton. So just for the completeness, I just wrote here. That's it. Okay. This is also a mathematics. In the beta plus decay of Sb to Sn, the maximum kinetic energy of the positron emitted is found to be 8.5 mega electron volt. If the atomic mass of Sb is that one, the atomic mass of Sn is how much? That is also very simple. Just I need to write here one thing. I think I have told so many times these things in previous year assignment questions. See, just remember one thing, when it is beta plus decay, there will be a Q value little bit different. When it is beta minus decay, then there will be a Q value little bit different. Okay? Actually, they are giving the atomic masses. In terms of atomic masses, there will be some difference in the expression for beta plus and beta minus. For beta minus, the Q value will be simply the atomic mass of parent nucleus minus atomic mass of daughter nucleus. Parent and daughter means you understand, this is the parent nucleus, this is daughter nucleus. For beta minus. But for beta plus, that will be a little bit different. Q value will be at the atomic
minus 2e.
Yes, minus 2e should be there, otherwise it will be wrong answer. And I showed you that how the minus 2e is coming into picture in any of the week. I forgot the week number, but still it's there. So here they are asking beta plus decay and they are giving the atomic masses. These two we need to take care so many times. Okay. So beta plus decay and atomic mass is given. So what we will do? We will simply do that. Okay, this is the Q value, maximum kinetic energy for positron, electron, whatever. That is giving the Q value. So Q value is 8.5. That is equals to mass, atomic mass. Let's say atomic mass of Sb minus atomic mass of Sn minus 2 Me. That is most important thing. This part is most important for beta plus decay. Okay. So now I think they are taking care about this one. So it will be like MAT of Sb minus 2 into Me minus 8.5. So yes. So now you can just calculate that one, that okay, this is in MEV, this is in U. Oh, nice. Just you have to take care. This is in U. So obviously you have to convert that one, 107.92216 into 931.5. That whole will be in MEV unit. So that will be there. Now MAT SN is 107.922, whatever it is given. I am not going to write all the terms. This minus 8.5 minus 2 into ME. ME is what? ME is 0.511 MeV. So this we can take care, and that will be in MeV unit only. And if they want to know the value in U, okay, they want to know the value in U unit, because you can see this is U unit. So then you have to, okay, if they are talking about U unit, then you have to take care all the decimal places, whatever it is given. 92216, and whatever it will be there, you have to take care all the terms, right? Then you will just do that, whatever the answer is coming, that divided by 931.5, that's it. Then it will be in U unit. Then you can have which one is the correct one. Actually, the A, B, C both are same. See, 107.919191. But the difference is in that after 3 decimal place. So obviously it is very crucial to have all the digits after decimal, whatever it is given. Okay, fine. So maybe that is also very simple. Then we can go to the next question as well. Obviously I could not cover all the topics here because there are so many topics, as I already mentioned to you, but you can see all the topics, but I was just showing you some of the flavor, that what can be the question, what type of question can be here, that's it. Okay, kinetic energy of alpha particle in an alpha decay is this one. If Q value of the decay is this one, the mass number of the parent nucleus is what? And write integer value because it is mass number. So for this case also, I think it's already very much explained so many times that the Q value is the kinetic energy of the alpha particle into A. A means the mass number.
So Q is equal to 80 by A minus 4.
That is the thing. So kinetic energy into A divided by A minus 4. Like, because the alpha particle is minus 4, I mean like alpha is E to 4. So obviously the parent and the daughter will have the difference in 4 unit. So then you can write here what they are asking. They are asking A value, and they have given the kinetic energy. Kinetic energy is 7.68 into A divided by A minus 4, that is 7.82. So now you can calculate the value of A. Maybe I can write it also. This is 7.82. 82A minus 7.82 into 4. You just need to calculate that one. 7.82 into 4. 31.28. 31.28. So 7.68 minus 7.82. A is minus 31.28. Obviously you can see that there is the minus problem. So it will be simply actually 7. Okay, I can write it correctly. That is the thing. Then it was 31.28. So you can see that, okay, the A value will be 31.28 divided by this is 4, this is 1, 0.14, like that. So if I calculate this, then it will be like 0.14, 223.42, 223.42. So it is of the order of 223 only. So this type of question can be there in your examination as well. I think I don't have any more question. Okay, maybe I should include more questions, but you can understand right now what will be the flavor of these questions. Like, that will be very simple question, but you need to check a little bit carefully so that you can answer all the questions carefully and correctly. So yeah, these things are there, and obviously this is a very short class because that is simply a wrap-up thing. If you have any doubt, any comment, anything, you can ask me, you can tell me, or so that others can also know that. Maybe I can go to the first Yes, this one, because this is the most important thing for our examination. So if you have any doubt regarding these things, you can just tell me. I will happy to answer the question. And then this I thought that most important topic, but if you want to add something more on that, that is also very much welcome. You can do that one. That's it. So yeah, I have told so many things. Now it's your turn to tell something about question, anything, comments, anything, doubts, anything.
Madam,
Yes.
I request that please you upload some notes related to this uh, workshop.
Workshop?
Okay, workshop or lectures. Okay. Uh,
Sorry, I could not get it. Can you please tell me again?
मैं चाहता हूँ कि ये जो अपन जितने भी लेक्चर हुए हैं अपने आपके इसके प्रॉपर यदि कोई नोट्स हो
See,
तो
like
वो आप
notes
हाँ
means actually what we are doing in an each every week we are solving the previous year questions, and previous year
यस
questions we are solving through that PPT whatever I am making, like that, like yellow color PPT.
यस
So
यस 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 यस
these I
बट
mean on that PPT itself I was telling, I was writing some answers, and maybe in some cases answers is already written in the this type of typing form, but most of the cases I am writing that one during the classes. That one was the note. I don't know, like any other note means what you want. I mean, if you want something more, obviously you can tell me, I can help you. But these were the notes for this courses, okay? I mean, from my side, these were the notes, as you can say. Because we are not teaching you, we are just solving the problems, previous year problems, that's it. Because we are the TA, teaching assistant, not a teacher. So,
नो 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 मैडम यू आर वेरी गुड टीचर बिकॉज हम कहें पॉलस पॉलस सर के एक्सप्लेनेशन से जितने हम सेटिस्फाई नहीं हुए हैं उससे कई गुना ज्यादा आपके लेक्चर से सेटिस्फाई हुए हैं बिकॉज पॉलस
okay, thank you so much for this compliment.
लेकिन उस थ्योरी का मैडम मैडम लिसन थ्योरी पढ़ाते थे प्लीज वो थ्योरी का जो एप्लीकेशन है
Yeah,
थ्योरी तो हमें आती है बुक्स में बहुत सारी लिखी हुई है हम वहां से उसको रीड कर लेते हैं
yes.
बट उसका एप्लीकेशन जो आपने एक्सप्लेन किया है दैट इज अ वेरी गुड आई थैंक यू वेरी मच ओके सो हम चाहते थे कि यदि हमें इससे रिलेटेड बहुत अच्छे क्योंकि आपके पीपीटी का यदि हम प्रिंट लेते हैं तो वो बहुत सारे पेजेस हो रहे हैं एक एक पीपीटी में आपके 83 पेजेस हैं अबाउट
Sorry to
ओके
say, but don't take the printout because my handwriting is very bad. So don't take the
नो नो
printout.
नो
You
नो
can,
नो आई अंडरस्टूड मैडम
yeah.
अब हम उसको समझ लेते हैं ओके हाँ सो ओके बहुत
Uh,
अच्छा आपने जो किया है और एक्चुअली क्या है कि ये हमें नेट के प्रिपरेशन के हिसाब से भी बहुत अच्छी चीज़ें मिली हुई है और हम बहुत थैंकफुल हैं आपके जो आपने इतने अच्छे से मतलब एक्सप्लेन किया
Yeah,
हुआ है
actually, see,
ओके
in NET, I can, I mean, personally, I can feel that if new NET के लिए nuclear and particle physics का जो question आता है, that is very simple. I mean, it's very, 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 very simple. हो सकता है
जी
कि जो न्यू स्टूडेंट है उनके लिए थोड़ा सा प्रॉब्लम होता है, बट इसमें ज़्यादा कुछ
जी
होता नहीं है, तो इट्स वेरी सिंपल होता है न्यूक्लियर एंड पार्टिकल फिजिक्स के लिए, तो
नो
दैट विल बी
देखिए
नॉट, या
आपके लिए देखिए जो जो पढ़ाता है उसके लिए बहुत सिंपल सी होती
हाँ,
चीजें लेकिन जो
नो नो इट्स
करता है
नॉट दैट मच, ओके फाइन, या सो
जी
तो मतलब व्हाट यू नीड लाइक notes, okay.
हाँ हाँ
How can I provide note? I can do one thing, like if time permits, I can do one thing that obviously you understand. I understand that there are so many pages in my. Huh? Hello. Oh. Hello. Okay. Sorry, I was disconnected.
कोई बात नहीं मैडम
So let me share the screen again.
थैंक यू मैडम थैंक यू
Yeah, so what I can do, as you told that there are so many pages on my slide, obviously because I need to give some spaces to write something, but obviously most of the cases, what I did, like there are so many blank spaces were there. So I can do one thing, that I can remove this blank space and I can upload that one in a Google Drive. That can be possible, but any other thing, any other note like thing, okay. What type of notes you want? Like theoretical notes? Hello, am I audible? Hello. Okay. Don't
Yes,
need
ma'am, audible, ma'am.
don't need to no need to raise your hand because I can't see your hand when I will present. So you can tell. You can unmute yourself and you can tell me. No problem. Yeah, so regarding that notes, okay, so I just want to clarify like what type of notes you want, like mathematics things, because we are basically in our previous year assignment, we are basically doing the mathematics, most of the cases mathematics only, but obviously some theory was also there. But I mean, for your future
Madam,
case also, what you need,
excuse me.
yes. Uh,
Madam, it is better to provide some notes on gauge transformations, madam.
Gauge transformation. Okay, very good. So maybe I'm just
I think
writing
it was
somewhere.
quite difficult. That's the thing.
Yeah, I'm writing somewhere
Okay.
in my notebook. So maybe I will
Hmm.
give you some. Obviously, my handwritten notebook notes will not be that much because like due to the time constraint and all these things. But I can refer some of the simple books or some of the simple portion of the gauge transformation book, so that you can just read that one and you can understand this. Okay,
Yes,
maybe
madam.
that will be a good one. Okay, I'm just
Okay, ma'am.
writing
Thank you.
that
Thank you.
one, gauge transformation. Yeah, I also feel that that is little bit tricky, so obviously you need something more specifically on that topic. Okay, very good. Then anything else topic, gauge transformation, and I think that field tensor, dual field tensor, this type of things is also very much needed. Okay, I'm just writing here with my note, maybe I can provide that one, dual field tensor. Okay, anything else you want? I mean, from the note perspective. Then we can go to the next person who is going to say something. No, I think, right? If you want something, you can tell me. Who were talking, I could not see. Vinod, Adnan, Vidya, Mukesh. Who told about the notes? Can you unmute yourself once again?
Regarding that, madam, gauge transformation notes are actually.
Okay, fine. Very good, very good. So maybe I will provide that one in Google Drive itself. Okay, very good.
Yes.
Any other question? There is something in chat box maybe? No, there is nothing in chat box. Okay, yeah, ma'am. Where these the questions that will come for the 15 schedule numericals? No, these will not. I mean, obviously, I can't say these will be numericals or not, but most probably that will come from direct question. Direct question means that this type of questions. What I wrote here. Let me write here. So you, let's say this one, or let's say. This W plus was there, na? There was a question of W plus mediates. So these type of questions can be there. Very simple. I mean, very straightforward question that W plus boson mediates which interaction. That type of question can be there in 15 questions. Okay. I mean, you understand that that is a 2-number question. So 2-number question is obviously not that much difficult. So this type of question may be there, W plus mediates or gamma mediates. Then anything else I can tell you, like what I can tell. Okay, there is something in chat box. No. And ma'am, for numericals, okay, I will tell you, just a minute. So direct question means for, let's say, Uh, okay, I can take one topic and after that I can say something on that. Right now I'm just thinking about this mediator. Okay, now you can say that they can ask that what is the isospin of sigma plus, sigma minus, sigma 0. That type of question can be there. That is a direct question, right? So, like sigma plus, sigma 0, sigma minus, what is the I value, what is the I3 value for this? I3 value is, this is plus 1, this is 0, this is minus 1, and I value is 1. So this type of question can be there. Or it can be possible that they will ask if 3 members are there in any, or if 2 members are there in any family, then what will be the value of I3? What will be the value of I? I will be half, because half into 2 plus 1, that is 2. So this type of question can be there. I mean, I'm just giving you one overview, that's it. So it's a simple direct question. There will be no numericals regarding these things, and it will be straightforward question. Okay, now coming to that numerical question you are asking. Numerical means that can cover that radioactivity part, because you can understand in radioactivity part 90% are numerical only. So from radioactivity there should be some numerical part. Then that spin parity, that is also regarded as, I mean, it can also be considered as numerical one. Then that mass number, binding energy calculation, then Q value calculation for beta minus, beta plus decay, that type of question can also be as a numerical. So numerical means the mathematics, that is the thing. Okay. Then anything else? And that tricky question means, I can tell you one tricky question. We have already solved that one in our previous class also. If you remember correctly, there was one question like there was epsilon mu, then a mu was there. They are asking that what is the value of E, like E vector, what is the value of E vector. Now you can see that for calculating E vector, that is not directly numerical value, right? They are giving the expression, and on the basis of expression we have to calculate the value of E vector. So that can be a little bit tricky question. I mean, that can be considered as a tricky question. Then the next tricky question I can remember is like what I can remember, this one, that f mu nu prime is equals to f mu nu or not. This can be the, I mean, obviously not that much tricky, but yeah. Then mu, then f mu nu mu, this type of transformation. Then any transformation will be given, and they will ask that this parameter is invariant under the transformation or not. This parameter, then special relativity question can be considered as numerical question. And then cyclotron question is numerical question definitely. Then what is else in my important topic list? That is my important topic list. Yes. Relativistic numerical. Allowed, not allowed is direct question, can be considered as direct question, as well as essay type question also. And then a plus b going to c plus x, that can also be considered as MSQ direct question also be there. Tricky question means one will be there. Tricky question, as per I understand, that there was one type of question like W plus or W minus. Only W minus mediator interaction is which one, or only gamma mediator is which one. You have to draw the Feynman diagram by yourself, so that you can feel that okay, this diagram is only governed by W plus, it is governed by W plus or Z0, that type of things. Maybe that is a tricky one. Anything else tricky? I can't remember right now. If you remember something, you can also discuss with me as a tricky question. और क्या हो सकता है? Okay, I mean, right now I can't remember any other tricky question. Anyone have any other problem, any other queries?
Madam, excuse me.
Yes.
Actually, isospin values having any relation connectivity. I think some connectivity is not there exactly. I think we need to remember perfectly for that isospin.
No, you don't need
Like,
to remember isospin for any particle. Okay, I can tell you one simple trick. Let's say let's say you know that sigma is in three member in their family. Sigma plus, sigma 0, sigma minus. That you know, right? Then cascade is in the two member in that family. Cascade minus, cascade 0. Then k plus, k0. Then k minus, k0 bar. These are one family, this is one family. This is a one family. Then p and n, this is also one family. So if you know these family members, then you can simply have the idea what will be the I3 for these values. Like let's say p. There are two members in this family. So two members means
1 by 2.
yes,
1 by
2 into I3 plus 1 equals to 2. So I3 will be half. I mean, not I3, it should be I. 2 will be I will be half. Now half is fine, isospin, but third component of isospin. So P is positive, so that means it is half. N is negative, that means it has minus half. I mean, N is not negative, N has the charge 0. I need to remember like that only, that P is little bit more heavier charged than neutron, right? Because P has a plus 1 charge, N has a 0 charge. So P has plus a half isospin, third component of isospin, N has minus half, third component of isospin. Similarly, you can see here also there are three members. So three members means I is 1. Now what will be I3 for these individual particles? This will be 1, this will be 0, this will be minus 1. Simple. Like because I3 is going from minus I to plus I. That means minus 1 to plus 1. Minus 1, 0, 1. Three values should be there for I equals to 1. Now which one will be in which particle, that we have to little bit think. But don't need to think that much, because if sigma plus is there, then obviously it will be plus 1. Sigma 0 is just beneath of that, so it is 0. Sigma minus is just beneath of that, so it is minus 1. It's like a stair, okay? 1, 0, minus 1. That's it. Now coming to cascade minus, cascade 0. These are the family members. So we know that two family members are there in that family. So it will be half. I will be half, simply. Now what will be I3 for sigma minus, cascade minus, cascade 0. So cascade 0. 0 is little bit higher than minus. So it is half, this is minus half. So cascade 0 is half, cascade minus is minus half. So like I used to remember like that only, that whenever it is like 0, 1, so 0 will be less I3 than 1. Minus 1 will be less I3 than 0. Like that only. Okay. So you don't remember each and every particle's I3 value. If you know the value, if you know the family members, then obviously you can calculate what will be the value of I3 for this particle corresponding this particle.
Okay, ma'am.
Yeah? Is
Okay,
it fine?
ma'am.
Yeah.
Yes, ma'am.
So that is the thing. Then again, like let's say, one more thing is that we need to think about strangeness number. That you need to remember a little bit. I think I had a table of the strangeness number. So here I just mentioned some of the important particles with their strangeness number. Obviously there are so many particles and you need to, I mean you can't remember all particles strangeness number and all, but just try to remember, like let's say for K plus strangeness is plus 1, for K minus strangeness is minus 1, like that you just remember a little bit. And one more thing I can tell you, quark content. Quark content also very much needed for some of the questions, but obviously we can't remember every particle's quark content. So one thing we can remember, we know that our S quark, strange quark. Okay, the strange quark has strangeness -1, that we know, right? So if we will talk about K minus, so K minus will have a quark content, something will be there, but with that only S will be there, because there is a strangeness -1, so S will be there. But for K plus, there will be something with that S bar will be there, because strangeness is +1. Do you got my point? Like, with the help of strangeness, we can see, we can a little bit confirm that what will be the quark confinement for this particle. We can't remember all confinement for all the particles. Even Einstein also can't remember this one. So what we will check,
Yes, ma'am. Yes, ma'am.
yeah, we will check, we will do a little bit trickness so that we can understand what can be the quark content. Okay, now you can ask me what will be this value. That you can understand from the charge, because here is +1 and S has charge is -1/3. So S bar, that means +1/3. So with this, what will be added so that it will be +1? This will be 2/3. So that means it can be U, it can be C, it can be T, but most probably K will be US bar. Then you can understand. So you see, I really did not know what is the quark content of K plus. I really did not know. But by seeing the strangeness and by seeing the charge, I can say that the quark content for K plus is US bar. Is it fine?
Yes, madam. Yes.
Yeah. So don't need to remember all
But need
the
to work more.
Yes.
Need to work more on this type of quark content.
See, like, okay, K plus you can remember, but for let's say anything else, you can't remember all the particles quark content. So that's why I'm telling, whenever you will forget the quark content, you will just think a little bit about strangeness and charge. These two are enough for getting the quark content of any particle. Let's say UUD. UUD, obviously we know that this is the quark content of proton. UDD. UDD we know that is the N1, N. So these
Neutron.
things we know, but whatever we don't know, for this particle we need to think a little bit. And obviously in your examination, if you will see something unknown particle and you at that time you will not remember the quark content, then you will little bit frustrated. But don't be frustrated. Just see the strangeness, just see the charge. Or let's say if this is not a strange particle, let's say for P is not a strange particle, so there should not be any S. That is definitely. So I mean, like that you little bit do yourself. I mean, obviously not in examination you have to do all those things, but before that also you can just try with this, you can just play with this, then we can understand. Okay, if we don't know any quark content, then with the help of other quantum numbers, what information can I get from this, and how will be the quark content for these particles, like that. Okay, then
Okay.
anything else?
One more doubt, madam.
Yeah, sure.
Actually, I'm trying to do solve this type of interaction, either electromagnetic, strong or weak.
Yes.
That is in we try to do energy conservation, momentum conservation, angular momentum, electric charge, lepton number, Baron number, etc. So at last we have some there is not conserved reactions are there. That is I am not able to explain properly. That is suppose if you want if you observe, madam, in both electromagnetic and weak interactions, parity, hypercharge, strangeness, and isospin component I3 or T3 numbers are not conserved. So sometimes maybe both it will be observed like both electromagnetic are strong or weak or like that. So how to distinguish them properly?
Okay, there is a table. I think I have shared this table somewhere. Okay, if it is not shared, then I can also tell right now. The main thing is that weak interaction does not conserve parity. That you need to know. Parity is not conserved in weak interaction, first of all. Strong interaction should be conserved parity. Strong interaction always conserve parity. Strong interaction always conserve strangeness quantum number. Strangeness quantum number is always conserved by strong interaction. I3 is also conserved by strong interaction. So whenever you will have some strong interaction, whenever you will have some interaction and they are asking that it is strong interaction or not, you have to check the strangeness I3 and all this. Then other than this, you know that QLB should be everywhere conserved. These things I am not going to tell right now. But for strong interaction, H and I3 should be conserved in every strong interaction. Now for weak interaction, I3 is violated. Okay, very good. Strangeness is also violated. Sometimes strangeness is not even conserved anymore. I3 is also violated. But for EM case you can see strangeness is always conserved. But I3 might be conserved or might not be conserved. So,
Yes, madam.
yeah, so in the context of I3 and AS, we can differentiate these three interactions. Strong interaction should conserve both of them. Weak interaction should conserve AS but not I3. EM interaction should conserve AS and may or may not be conserved by I3. So now you can understand, we can have a little bit idea that which interaction it should be. But I can tell you one trick also. Whenever you will see any interaction governed by gamma, that is definitely a EM interaction. And whenever you will see any interaction with neutrino, that is definitely, no doubtly, it is a weak interaction.
Weak interaction.
Yeah, these two we can have without saying all these things, without checking all these things. We can directly say. And whenever you will have any strange particle, okay, I will tell you one thing. Whenever you will see any strange particle, most probably 90% case it is a strong interaction. Obviously not 100%, I am telling, so emphasizing that not 100% I am telling, but if in any nuclear reaction one strange particle is there, strange particle means which strangeness number is non-zero. If it is strange particle is present and both left hand side and right hand side strangeness quantum number is conserved, in 90% case that is governed by strong interaction only. Okay, obviously I am telling there are some exception on that, but most probably it is governed by strong interaction, most probably. Okay, so this is the thing. And
Okay.
yeah, and one more thing, I think it should not be in your topic, but I can tell you this, that of hello, okay, I was disconnected. So I just wanted to tell you that one strange particle can, one strange particle means where a strangeness number is non-zero. One strange particle can decay in weak interaction with strangeness quantum number not conserved. As I told you right now that in weak interaction strangeness is not gonna conserved in weak interaction. So whenever one strange particle is decaying into some other particle which is non-strange, so that means in left hand side strangeness quantum number is there, but in right hand side there is no strangeness quantum number. That means as a whole there is strangeness quantum number is violated. So obviously that will governed by weak interaction. So there is one statement that strange particles are produced through strong interaction, but they are decaying through weak interaction. You understand the point? Strange particles are produced through strong interaction, but they are decaying through weak interaction. Because obviously whenever they will decay, the strange particle will not, the interaction will not be conserved strange interaction, strangeness quantum number, so it will be a weak interaction. Maybe I can write it somewhere in my note. I don't know if it will come or not. Just a minute. I can write here it's very important. Maybe it is not that much important for your this examination, but later also it will be very much important. So it's strange particles. Strange particles produced. Produce via strong interaction. Okay, but they decay via weak interaction. You can see that one, you can observe these things in any nuclear reaction. Whenever we are taking care about the strange particle, they are most probably producing via the strong interaction, but they are decaying via weak interaction. So maybe I thought that is important, so that's why I just written here. Okay, any other question, any other doubt, any other comments regarding exam, regarding nuclear and particle physics course, regarding whole chapters, whole topics, anything?
Right now, okay.
Okay, na? Okay, very good. So I think you have the exam on 3rd November most probably. I'm not sure that it will be on 3rd November or not.
Yes, ma'am, it is on 3rd November.
Yeah,
Sunday.
it's on 3rd November, Sunday. So all the very best for your examination, and whatever you people told that gauge transformation notes, I'll provide some notes on the Google Drive itself, so you can have a look on that, and this PPT will also be uploaded in that Google Drive, and
Okay.
so that you can have the
Thank
idea
you.
that what will be the exam pattern and all. And anything else, I don't think anything else is important. So yeah, that is the thing, and all the very best for your examination. Not only this examination, all the very best for your all upcoming future examinations. So
Thank you.
yeah, so okay, bye bye. Ma'am, where will be the Google Drive? Oh, where will be the Google Drive? Okay. Actually, I am sending the Google. Okay, let me give one time. I'll send you the Google Drive link right now itself. Just a minute. Okay, maybe I can have. Okay, sorry, I was disconnected again. So I'm sending the Google Drive link. You can see the Google Drive link, and maybe whenever you will open the link, maybe you need access. They will ask for access. So just send me a mail. I will give the access for you. Okay. Whoever asking the question, I don't know who was asking the question. This is the Google Drive link. You can just copy it and open it. Yeah, fine. So if you give me one notification, then I will give the access. Maybe I got the notification, but I will do that after the class. Okay. Okay. So yeah. Okay. So any other question, any other doubt, or otherwise we can have no. There is no other classes, but this is the last class.